Okay, so let's do it again. This time we've got a brand new expression, one that looks kind of awfulish. And let's take our derivative of y with respect to x. And this time without a lot of preamble. You can go back and see the rule that I use. We're going to be using a product rule here because we've got x squared times y squared as one of the terms. And we're going to have to figure out dy dx from all of this. So let's run through it. We're going to take the derivative. I'll get my pen to the color that I want it to this time. The derivative with respect to x of our left-hand side. So we've got 2x squared y squared minus 3x plus 2y on the left. And we're setting that equal to the derivative with respect to x of the constant 5, which we know that derivative will come out to 0, but we'll work with it. Okay, so we're going to take the derivative with respect to x of each term, so I'm going to take 2 times the derivative with respect to x of x squared times y squared minus 3 times the derivative of x with respect to x, well that's 1, plus 2 times the derivative of y with respect to x, and that will equal 0 on the right hand side. So now we're going to have to use our product rule right here with this very first term and then distribute the 2 through it. So what happens? Well, it'll be 2 times the first function, so that's x squared, times the derivative with respect to x of the second function, which is y squared. Again, y is implied to be a function of x, plus the second function y squared times the derivative with respect to x of x squared, so that's our product rule, minus 3 plus 2 times dy dx. And again, all of that is equal to 0. So what we're going to do here is we're going to take our derivative of each of these terms individually. So there's one more differentiation step to take. We would take 2 out here. We're still taking the differentiation, so we're going to take x squared. Our derivative of y squared, we know that's going to be 2y. And since y is a function of x, like our chain rule, we say that's dy dx here. Plus, and then we're going to take y squared times the derivative of x squared. We know that's 2x times dx, that's just 1, minus 3 plus 2 times dy dx. And the rest of this now becomes one huge algebra problem, right? We have 2 times x squared times 2 times y times dy dx. So shortening that a little bit, that's 4x squared y times dy dx plus, we've got 2 times y squared times 2x, so we're going to shorten that to 4xy squared minus 3 plus 2 times dy dx equals 0. And so our next step is to isolate our dy dx terms and this time we'll move the non-dy dx terms to the other side by addition or subtraction. So we're going to get a new expression. It'll look like this. In our equation, we balance it and we say 4 times x squared y times dy dx plus 2 times dy dx will equal 3 minus 4xy squared. So taking 4x squared y plus 2, and by the distributive property, factoring out dy dx, that will be set equal to 3 minus 4xy squared. And I'm going to write my derivative this way. We divide both sides by 4x squared y plus 2. But there is a certain symmetry right here because we're taking 3 minus 4xy squared in the numerator, and in the denominator, if I change around the order of the terms, I'm taking 2 plus 4x squared y, which is kind of interesting. And this would be our derivative uh, that we could evaluate for any given value x and y, any coordinate point x and y if we knew it on this graph. And so we're done.